Hey guys, today we are going to talk about our last different form of graphing lines, and it's called standard form. So we are on pages 19 and 20 in our notes, and we are just going to talk about, we're going to start off actually with a word problem. So a local museum has a special bug exhibit. Adult tickets cost $11 each, and child tickets cost $5 each. A group spent a total of $55 on tickets. If X represents the number of child tickets and Y represents the number of adult tickets, write a function to represent the situation. So it tells us what the two variables represent. So in this case, X is representing child tickets. And so we know that for every child ticket X, it costs $5. So 5 for every X number of tickets. Okay. Then we also know what the other variable represents, which is your Y variable, and that represents your adult tickets. So adult tickets cost $11 each. So for every $11, you get an adult ticket. Okay. And the final thing is we know a grand total. So I know total means we need to add those values together. And the grand total is $55. Okay, so this is our first equation in standard form. This is a little bit different than y equals mx plus b. Y equals mx plus b means you have this one rate that affects your unknown total or your amount. Okay, this problem, we actually know what the total is. And what's happening is we have varying amounts of change. We have the adult tickets and we have child tickets, and both of those are affecting a total that we do know. So we have to kind of problem solve to figure out, well, if we have one ticket of this, how many tickets would we have to figure out for that? So standard form is very helpful in real world situations where we don't just have a y-intercept and a one rate. This problem, we have two rates affecting a total that we know. Okay, so this form of a linear equation is called standard form, and it's used in a lot of real world situations. So this equation is called is ax plus by equals c. So in standard form, the a, b, and c values are integers. Okay, so integers just mean there are no fractions, no decimals. They are just whole values, positives or negatives, whose greatest common factor is 1. So we'll talk about it. Just needs to be simplified. It's not big factors. Okay, a must be a positive number, and a and b also cannot be the value of 0. Okay, so we're just going to kind of go through each and see if this is in standard form or if it's not in standard form. Okay, so for this one, 3x plus 4y equals 13. So the first thing is a, b, and c are integers. Yes. Okay, a is positive. Yes. And a and b are not 0. So this is an equation in standard form. Okay, this equation does not match this at all. So this is definitely not in standard form. That's actually in point slope form. Okay, this next equation, they are all in integers. They look similar, but a has a negative value, and just one of the plain definitions is that a always has to be a positive value. So how it's written right now, it is not in standard form. All right, this next one, a, b, and c are all integers. A is positive, and we have no 0 value, so this also could be in standard form. This last one, or the second to last one, 3/4 x plus y equals 6. This right here, this is not an integer, it's a fraction, it's a rational number. So technically, because this is not an integer, it's not yet in standard form. We could put it in standard form and we will later, but not right now. And then this very last one, a, b, and c, it looks like the form, they're all integers, and a is positive, and these are not 0, so this is also in standard form. Okay, linear equations written in standard form can be especially helpful in finding our x and y intercepts. Okay, so we've dealt with y-intercepts before, but now we can just look at an equation that's in standard form and mathematically calculate the y-intercept by just doing one little math problem and finding the x-intercepts, which will be helpful when we get to curves and stuff like that. Okay, so the y-intercept is the point where it crosses the y-axis. And the x-intercept, also known as a 0, is the point where the graph crosses the x-axis. Okay, so what we're going to do first is we're just going to look at a graph that's already graphed for us, and we are just going to first locate the x and y intercepts and to label them as ordered pairs. Okay, so this is the y-axis, and it crosses the y-axis right at 6. So as an ordered pair, this would be 0, 6. So here's our y-intercept because it crosses the y-axis. So just write int. And as an ordered pair, that is 0, 6. Okay. Then we also have this x-axis, and this line also crosses the x-axis as well. So this is our x-intercept. Okay. And as an ordered pair, it crosses at 8. So as an ordered pair, that would be 8, 0. Okay. So the cool thing about intercepts is calculating them is not very hard, because looking at a y-intercept and an x-intercept, there's always the value of 0 in an ordered pair. So an x-intercept will always have a y value of 0, because that's where visually it's crossing the x-axis, so it has no y to it. Okay, and a y-intercept will always have an x value of 0. Okay, so an x-intercept is sometimes called a 0 because it's when it has no y to it. Okay, all right. So for these two problems, it says to calculate the x and y intercepts in the functions. Use the points to graph the function. Okay, so first what we're going to do is we're going to find our x-intercept. Okay, so an x-intercept will always have a y value of 0. So what I'm going to do is I'm going to put y equals 0 in for our function. So x plus 2y, so I'm just going to put 0 in. Okay. 2 times 0 is 0. And so x equals 6. So my x-intercept is x equals 6 when y equals 0. So as an ordered pair, 6, 0. Okay. I could also just find the y-intercept, so I'm also going to do that. A y-intercept is when the x value is also 0. So I'm going to say, okay, x equals 0. So I'm going to rewrite this function again with a 0 for x. So 0 plus 2y equals 6. Okay, well, 0 is nothing. Then I have 2y equals 6. I'm going to divide by 2. Y equals 3. Okay, so as a y-intercept, this is when x equals 0, y equals 3. So x equals 0, y equals 3. And I just figured out that this graph looks something like this. Again, just getting a rough sketch of it. So this is just helpful. Sometimes it's not in slope-intercept form or point-slope form, and this is just another way to just calculate, which is by your x and your y-intercepts. Okay, so let's go ahead and try another problem. 4x plus 7y equals 28. Now, I'm not saying that you can't just solve for y and graph it that way, but again, we're just practicing various ways because x and y intercepts will be very helpful when we get to curves. Okay, so we're just going to understand hopefully the concept. So first, we're going to find the x-intercept. Again, I'm just rereading this. An x-intercept will always have a y value of 0. So I'm going to say y equals 0. So I'm going to rewrite this function, 4x plus 7, but now instead of y, I'm going to put 0, equals 28. 7 times 0 is 0, so I have 4x equaling 28. Divide by 4, and you get x equals 7. Okay. So my x-intercept is when x equals 7, my y value is 0. So this is x, this is y. I could plot that right there. Okay. For our y-intercept, we're going to say that is when x equals 0. So again, I'm going to rewrite the original function, but instead of x, this time I'm going to put 0. 4 times 0 is 0, and I'm just left with 7y equaling 28. Divide by the 7, and I get y equals 4. Okay, so when x equals 0, my y value was 4. So my y-intercept is 4. Okay. So now I'm just going to connect those the best that I can. So again, this is just a rough sketch. We're just checking to see if you have the x and y intercepts correct. All right, let's go ahead and go to page 20. In 3 and 4, we write each equation in slope-intercept form, then list the slope and create a graph. So this is just saying, hey, you can convert equations in standard form into slope-intercept form, and the way we do that is just to solve for y. Okay, so if I need to get y by itself, I need to remove first the 4x, so I'm going to subtract the 4x. Okay, I got with a subtraction. Positive and a negative is a 0, so then we just have 6y's equaling 12 minus 4x. Again, these are not like terms, so you just have to write what you have. Okay. Then I'm going to divide by 6, and when I do that, I just have to make sure I divide everything by 6. Okay, so I have y equals 12 divided by 6, which is 2. And then I have negative 4x divided by 6, and this is my slope, so I'm going to simplify. Negative 4 to 6 would be simplified to negative 2 to 3. And so my equation is 2 minus 2/3 x. You could also write it as, I'll write it over here, y equals negative 2/3 x plus 2. Okay. So my slope is negative 2 to 3. So to graph this, we always have to have our starting point, and our starting point is still our y-intercept. So we would start at 2, and then our slope is down to right 3. So I can actually see that the x-intercept is 3, which is cool. Okay, down to right 3, down to right 3. Okay, then I'm going to go backwards and go up, left, up, left. For number 4, we have 7x plus 5y equals 35. Again, it's asking us to convert it into slope-intercept form. So I need to solve or isolate the y. So this is a positive 7x, so I'm going to subtract the 7x. 5y equals 35 minus 7x. Now I'm going to divide by the 5. Y equals 35 over 5 is 7. Then we have negative 7x over 5. I can't simplify that, so I just have negative 7/5 x. Okay? Again, you could also write this a different way. You could just write it as mx plus b. Both are correct with the community property. Okay, the slope is the rate, which was negative 7/5. So to graph this equation, we would have to start at our y-intercept, or our starting value, which is 7. And then it says to go down 7, right 5. So I'm going to go down 7, kind of use my imagination, probably be right back there. Okay, so this problem says use your knowledge of standard form to answer questions 5 through 8. Ureli is going to graph the equation 8x plus 3y equals 24. Describe the following. A, where will the 0 of the graph be? So 0 is kind of a new term. So if we go to the front of our notes, okay, the x-intercept is also known as a 0. So the x-intercept is when you have a y value of 0. So I'm going to say y equals 0. And I'm going to actually use this function and rewrite it where y does equal 0. 3 times 0 is 0. And so we just have 8x equaling 24. Divide by 8, we get x equals 3. So a 0 would be this x-intercept of 3, 0. Okay. Part B says, will the point 3, negative 5 lay on this graph? Okay. Well, we just actually figured out when we put an input of 3, we're going to get out 0 because we solved this equation or found this 0. So when x equals 3, y equals 0, so it does not cross at negative 5. Okay. Number 6. Hans paid to enter a fair where he could ride various rides. The situation can be represented using the equation 5x minus 2y equaling negative 30, where x is the number of rides and y is the total cost. Okay? Part A says, how much does each ride cost? So it's asking us, what is the rate? What is the rate or the cost per ride? Okay, so we know that there are 5 rides because that's the number of rides. Okay, and y is the total cost. So it's taking out $2 every cost. Okay, so what we need to kind of do is probably need to manipulate this equation to find the rate or the cost for every ride. So what that means is we're going to have to solve and put it basically in slope-intercept form. So we're going to solve for y. So 5x minus 2y equaling negative 30. So first thing we are going to do is subtract 5x. Negative 2y equals negative 30 minus 5x. And now we are going to divide by the negative 2. Okay. And we have this equation, y equals negative 30 over negative 2, which would be 15. And then negative 5x over negative 2, which would be just converted to a positive 5:2 ratio x. Okay. So this is our equation, and now we need to interpret it. Okay, it says, well, how much did each ride cost? Okay, so that means I need to find my slope. Okay, so it tells me that this is $5 for every 2 rides. Okay, so I just ran out of room, so I'm just going to erase that part. Okay, so it's saying the slope. Okay, so I need to find my m. We found that it was $5 for 2 rides. Okay, and because it's a word context, we could simplify this and to interpret that this would be about $2.50 per ride. Part B says, how much was the entrance fee? So we have to think about this fair. First, they have to get into the fair, and then they can go on all of their rides. So when it says the entrance fee, it reminds me of like the starting value or the starting point. So in this case, I want to find the y-intercept. So since we already solved for y, we can just visualize and see that the starting cost is $15. Okay, and I found that by finding the b. Okay. So again, when it says cost each ride, those are 2 variables that we're comparing. So that means I have to find my slope because slope is the ratio of 2 things. Okay, so that's how I knew I had to find slope. And then this said, what is the entrance fee? So I had to think about the starting cost. So it reminded me of y-intercept. Okay, which of the following represents the equation of the graphed line? Okay, so we have this graph line. It passes the x-axis at -6, and it crosses the y-axis at -4. So we have to decide which one would give us that exact answer. Okay, so we could just solve for y each time and see which one would start at -4 and have a negative slope. We could do that. Okay. Or we could just kind of just do a couple problems and see which one would also give you the same thing. Okay, so I'm going to find x-intercepts first and see if we can eliminate any of them. So an x-intercept is when you have no y value. So again, I want it to be -6. So we could put in -6 in here, okay, into all of our x's and see what we get out. That's another great option. Okay, I just like to do when y equals 0. So when y equals 0, this just makes a 0, and we have 3x equaling -12. So x equals -4. So it cannot be A because -4 is right here and we need -6. All right, so for the second one, we have when y is 0, 3 times 0 is 0. So I have 2x equaling -12. divide by 2, I get x equals -6. So right now it could still be B, okay? For the third one, this is again x-intercept when y equals 0. 3 times 0 is 0. So we have 2x equaling -19, and we get x equals -9.5. So I know it cannot be C just by finding the x-intercepts. All right, last one. X-intercept when y equals 0. 2 times 0 is 0. And we're just left with x equaling -4. So again, it cannot be D because we need an x-intercept of -6. Okay, so it has to be B. This was just one way you could have done it. You could have plugged in -6 for x and 0 in for y and seen which one gives you the right answer. You could have converted all of these into slope-intercept form and saw which graph matched, giving you just plenty of different options. Okay. And the last problem, Pedro has $18 to spend at the grocery store. His mother wants him to use the money to buy fruit. Apples cost $2 a pound and pears cost $3 a pound. Assuming X represents the number of apples and Y represents the pounds of pears, write an equation to represent the situation. So we have X representing the pounds of apples. So we know cost is $2 a pound. Okay? And Y represents the pound of pears, and pears cost $3 a pound. Okay? And we also know that the total is 18. So when I write this equation, I know $2 a pound for apples. I'm going to add, because we're finding the total, $3 a pound for pears, two different things, so two different variables, and that gives us a result of 18. I know what the total is for this situation. Okay, it says first, what is the x-intercept and what does it represent? So x-intercept, that is when we don't have any y values. I want to know when y is 0. Okay, so I'm going to plug that in, 2x plus 3 y's or 3 zeros. Okay, then 3 zeros is just nothing. So I have 2x equaling 18. So I have x equals 9. Okay, so as an ordered pair, I have 9, 0. What does this represent? Well, in this situation, Pedro could buy 9 pounds of apples, 0 pounds of pears, and it will still be equivalent to the $18 that his mom gave him. Okay. Then it says to find the y-intercept. Okay, so the y-intercept is when x equals 0. I want to know where it crosses the y-axis. So I'm going to rewrite the function when x equals 0. 2 times 0 is 0. So now we have 3y equaling 18. So I'll divide by 3, and I get y equals 6. So as an ordered pair, this is when x equals 0 and y equals 6. Okay. So what does this represent? This means we have 0 pounds of apples, 6 pounds of pears, and with that situation, we still have a grand total of $18. Okay? And the very last thing it says is to use the x and y intercepts to graph it at the right. Beautiful. Okay. All right, so the last thing we will do is tomorrow we are going to practice this in person. So make sure you feel comfortable with this and reflect and see what you kind of need a little bit more help with. See you guys tomorrow.